Hey you guys, welcome back to another episode of Physics, and to this episode we're going to talk about the rate of change of momentum. Now, I'm going to give you like maybe three little quick tips about the rate of change of momentum, what you should do before we go hit the problem. The first thing you need to do when you see a rate of change of momentum problem is that you need to draw your system. If you draw your system out, it will help you so much, significantly. Like, it will just help you so much if you draw your system out. The second is that you need to know the momentum principle equation. The momentum principle equation is a very simple equation. You can totally remember, and you need to take that equation and put it in the back of your mind because you're gonna use it a lot in physics. This is the equation where this means the change of momentum equals the force. This is the momentum principle equation, and this we need to use the momentum principle equation to relate the net force, that the change of momentum and the net force are different quantities separately evaluated. The momentum principle tells us that these two vectors have the same vector components. Very easy to understand. So let's go hit our problem of today. So our problem of today, so you go to your house and you discovered that one of your friends took all your stuff in your room and put it in a box. And your friend's driving a Cadillac, a car. I don't know what kind of car. I said Cadillac. I like Cadillacs. And he ties a rope with an angle of 35 degrees. And all your stuff in that little box weighs 40 kilograms. If the frictional force is 0.5 and your friend is going at a constant speed at an x direction, what is the tension force in that rope? You're probably real pissed at your friend because he's doing this to you. But just like I told you, first draw your system. Draw your system. It will help you so much. So right here, I drew my system out. And I have the box. That is the rope that's connected from the box to the car, and this is my tension force. My tension force is going, it technically is going this way, but this is my tension force at an angle. I have the gravity because Earth is pulling down on my box, and I have the normal force where my box is pulling up. It's trying to go up while the Earth is pulling it down. And I also have my friction force going on this direction because my friction force is trying to slow down my box. Now, like I told you, we need to know the momentum principle equation, where the rate of change of momentum equals force net. And I know by drawing my system that the change of momentum is equals to the normal force times frictional force plus gravitational force plus tension force. And we're trying to find tension force. That's why I put all these little lines. Now, some of you think, why are you putting vector signs in there? Well, this is a vector. He's going in an x direction, so this means all these numbers, all these quantities are in vector form. So to make your life and my life easier, I tend to separate my vectors equation like this, where I'm just trying to find the first, like my first section, and then I try to find my second section. What I mean is x. So I know that nx, normal force x in the x direction, plus the frictional force in the x direction, plus the gravitational force in the x direction, plus the tension force in the x direction has to be equals the change in momentum in the x direction. And I know the change in momentum is 0. What would you say? Well, it's 0 because your friend, whoever is doing this to you, is driving the car at a constant speed. So the rate of change of momentum is 0. Now, the normal force is 0 because the normal force is acting in a y direction, you see? It's going up, not in a side. So this is 0. And the gravitational force is also 0 because it's just like the normal force. It's acting in the y direction. So this is 0, this is 0, and this is 0. And I know that the frictional force going in the negative side, plus is slowing your thing down, it's negative, plus the tension force cosine of 35 degrees equals to 0. Now, let's do the same thing we did here on the y section, where normal force on the y plus the frictional force on the y plus the gravitational force on the y plus the tension force on the y direction equals the tension rate of momentum on the y direction. Same thing here. The rate of change of momentum is the speed is constant, so the rate of change of momentum is 0. The frictional force is 0. So I only have the normal force minus mass times gravity plus the tension force sine of 35 has to be equal to 0. Now, I did a little thing here where I know that the frictional force has to be equals the friction coefficient times the normal force. And I substitute here where frictional force has N equals T cosine 35. And because I have two unknowns, I have my N, I don't know what N is, and I don't know what T is. Because I solve here for N, I can plug in N for this N, making this. Now I did a little of algebra array here. This is very simple algebra where you just have to plug in the N in here and separate. You have this right here. And if you expand, collect all your T's, and then take a T out, you get something like this. T equals the frictional force mass gravity divided by the frictional force coefficient sine 35 plus cosine 35, and that's just a plug-in game where you plug in all your values, and you will get 69 newtons. Thank you.